Hello, I'm Robert Richter here on behalf of Orbital Technologies Corporation. We're also known as ORBITEC. And a little bit about ORBITEC. We're a small business located up in Madison, Wisconsin. We're really based on our staff. Our staff has significant experience flying payloads, working for previous aerospace companies and institutions. Our scientist on staff has over 20 years of flying science payloads. And we've done everything pretty much from hardware development all the way through flight operation, post-flight operations. Next slide, please. I'm going to get more into some of the hardware that we've worked on. And if you have any questions about any of the processes or anything in between, please stop by and contact me and I'll describe it in more detail. Next slide, please. The first payload I'll talk about is the Biomass production system, and if you haven't noticed already, everything within the aerospace community has an acronym. So if you don't know what an acronym means, please feel free to ask as well. The Biomass production system flew in 2002. Earlier this year, a NASA scientist associated with this payload gave us the ultimate compliment of, to date, he feels this payload has provided the best plant data ever recorded. So that was a very nice comment on his behalf to us. And again, this payload we developed all the way from the requirement stages through flight operation. Next slide, please. Here are some of the parameters for this plant unit. It controlled temperature, humidity, and gas composition, light levels. It actually was a sealed chamber in which they were able to conduct CO2 drawdowns, something that previous plant experiments were not capable of doing. Next slide, please. Here are some of the images that were actually collected on flight. The left two are actually from the payload itself, and the other two are from crew while they were transferring the payload and harvesting the plants during flight. Next slide, please. As an upshot of the BPS payload, we also developed an express rack interface rack system that could also be mounted in the shuttle mid-deck. There's slight variation mounting adapters needed as well for that. So again, these are just types of interfaces we're used to developing and designing, working with. Next slide, please. After the BPS, we actually worked on another configuration of the BPS, and that was different chamber configurations. Some scientists wanted 4 chambers so they could be redundant in their experiments. Others wanted taller plants. Some people want larger growth volumes, areas. And really what this is meant to show is that we're really flexible and like to work with the PIs to try to develop something that they really would like to use and fits their need best. Next slide, please. Another important factor with science payloads, really developing the science protocols on the ground in parallel with while your hardware is getting processed for flight certification. And that's where we have science evaluation units for plants in which the scientists can actually take these chambers, recreate an environmental chamber on the ground and work through their protocols so that when it gets time that they need to submit their science protocols, that they're all ready and tested. Next slide, please. Another simplified system that's flown before is called the Astrogarden. And this is really a passive system. You insert water, it has its own nutrient system. It's used to grow plants in space. This is really more for educational payloads as well as educational payloads and crew. We recently had the Italian astronaut request one of these units so he could fly up and have a hobby to grow plants. So next slide, please. What we did is we actually did the verification and everything so it could fly up on ATV and submitted the safety data package for the Astrogarden. Similar to our previous speaker, you know, the Astrogarden was on the order of ounces. The paperwork associated with something simple and passive was on the order of tens of pounds as well. So next slide, please. Here are just some representative crops that have actually been grown in the Astrogarden. Next slide, please. Another piece of hardware that's currently at the Kennedy Space Center is called the Vegetable Production System, or as we know it, the VEGGIE. And this is a more passive system that utilizes more current technology, solid-state lighting. Next slide, please. It does utilize ambient gas for control of temperature and gas composition, but what it does offer is a larger growth volume at a much reduced and simplified mass and interface. Next slide, please. One of the benefits here is that we actually control the light that's provided to the plants in the spectrum that's usable by the plants. So it's just more efficient. Next slide, please. Another habitat in which we've done significant development on is called the advanced animal habitat, and this is being designed for mice and rats. And we've actually gone through the prototype build hardware phase, which we'll actually get into on a couple slides here. Next, please. Here are some of the capabilities of the advanced animal habitat. This is an active temperature control system. We were able to monitor water and do video surveillance, as well as have real-time data collection and communication with the payload was the end goal. Next slide, please. And just to show some of how far along we were, the cage in the upper left-hand corner was actually through the crew process. And anytime you have something that folds or could become a pinch hazard, it's very critical to get the crew involved at an early stage to get their approval. So the cage was actually approved for flight, which is a huge step. And that's actually astronaut Mark Lee in the bottom right-hand corner doing a fit check to make sure he could access the cage as needed. Next slide, please. And just again, some more of the hardware associated with the advanced animal habitat. Next slide, please. We've done quite a bit of biocompatibility testing and testing with live samples. This is a fake one just to show the capabilities and make sure we're getting the video coverage we were required to. Next slide, please. And much like the plant one, it's very important to have a science evaluation unit so that the scientists can develop their protocols in parallel while the hardware is either being verified or certified for flight. So we actually have this hardware. This program was started under the Space Station Biological Research Program and was terminated about 5 years ago. ORBITEC believed that this capability would be needed in the future and actually invested and procured the hardware so we could use it at a future time. Next slide, please. As an upshot of some of the biological payloads we've also developed customized lighting systems, be electrically efficient or photo period efficient. We've done systems, the one in the bottom is equivalent brightness of a sun. So it just shows the capabilities and thermal management capabilities we have with lights. If you have an application where you need custom lighting, please see us. Next slide, please. Along with some of this hardware, this slide just kind of summarizes some of the integration and operation support capabilities we have at ORBITEC. We conduct a lot of the verification on the hardware at ORBITEC. We've invested significantly in test capabilities. What it allows us to do is really keep to our schedule and keep things flowing in a productive manner. We're not traveling to this lab to do this test or that lab to do that test. We have a lot of those capabilities in-house. We also have the ability to do virtual crew training. It's known as a hypercosm player, which is a 3D virtual system in which we actually modeled recently for Wiley the T2 or Colbert treadmill. And what it did is it actually showed the assembly process. So we feel that's another advantage of being able to rapidly train or make modifications and provide crew training updates. And again, if anybody has any questions on our capabilities or some of the hardware that we have, I encourage you to please stop by. We have a table and talk to us. Thank you.